Welcome to Vision Plus and welcome back to this senior for mathematics and complex numbers. We are doing argument of a complex number and we are starting with example 1. Before we go to example 1, there is an NB here that says, to avoid confusion, we normally work with the values of the angle theta in the range of negative pi and pi, or in the range of negative 180 degrees and 180 degrees. And this is what we call the principal argument. So we're going to example 1. Example 1 says that we are given three complex numbers, and the question says that we need to find the principal argument. So for part A, z1, which is given as 3 plus 4i, here we need to find the principal argument. It means we need to get the angle if the complex number z1 makes with the positive x-axis. So to do that, it is better and it's always easier for us to get the answer when we represent the given complex number on the diagram. Then from there, we get the angle. There is a formula which is shorter, but that formula does not always give correct answer for every complex number. So the only way we can get all our answers simply is by drawing the Argand diagram. So for part A, let me draw the Argand diagram. This is the real axis, which we can say this is the real part of the complex number Z1, the real axis rather, and then this is the imaginary axis of the complex number Z1. That saves your time. Now, we need to represent 3 and 4. So you come and label your axis, make this one longer, make this one longer. That means I'm going to represent 1, but there is no sin when you just come and represent them straight away. On the real axis, we have positive 3. Just come and say here I have here positive 3. This is the origin. That means on the other side, you will be having here negative 3. And then on the imaginary part, which is on the vertical axis, we need to represent 4. But 4 is bigger than 3. So we make it further away from the origin than 3. This is negative 4. And then from here, you get the point of intersection of 3, which is positive on the real axis, it is there, and 4 positive on the imaginary axis, which are these two are going to intersect at that point. That is the point where they are going to meet. So we just mark this the point of intersection with a dot, of course. Then we draw a straight line with an arrow at the top. We draw an arrow at the top, and then we say this is the complex number Z1. But that is not what the question says. The question says that the principal argument. So this is the angle. This is the argument that we are looking for. That is the angle. So what can we do here? How can we get that angle? Now, this is going to be a right angle triangle. We can extract right angle triangle from this drawing. And all the complex numbers that we shall have are going to be right angle triangles. They will form right angle triangles. So, because we say that from here up to here is 3 units, is 3. Then from here up to up there is 4 units. So from here up to here is the same as from here up to here. So that means here is also 4. So if I'm to extract this triangle, to look at there is this dotted line there, it goes down, then this is where the origin is. So from here up to here, this is the angle that we are looking for later. This is where the origin is. So from here up to here, we have said it is 3 units. From here up here, it is 4 units. It is the same as from here up to there. Now, how do we get this angle here? For us to get the angle, we need to apply the property of SOHCAHTOA. SOHCAHTOA. You need to know that this is the hypotenuse, this is the adjacent to the angle, and this is the opposite to the angle. Now you have the opposite to the angle. Please, we are applying that concept here, and it is not our main idea. So in case you don't know it completely, please go and revise it before you continue. So if you see here, we have the opposite. This is the opposite. This is the adjacent. This is the hypotenuse. Now we have the opposite and the adjacent, which we are going to say opposite and adjacent. That gives us here that we need to take tan. So we say that tan of angle theta is opposite over adjacent. And then we substitute now. That means here tan of the angle we are looking for is, what is the opposite? Opposite is 4 out of adjacent. Adjacent is 3. But we are looking for the angle. So you say both sides by tan, both sides by tan. So that here our angle theta here becomes tan inverse of 4 out of 3. Then you press your calculator. You press tan inverse. How do you press tan inverse? You press shift and tan. You see there tan inverse or arctan of 4 divided by 3 is giving me 53.13. Let's write them to 2 degrees. So this is the angle. This is the argument of z1. This is the angle that it makes with the positive x-axis. Therefore, argument, which is z1, this is argument of z1 is 53.13 degrees. Now, this is the direction of that complex number. Remember, we said the complex number has both the size and direction. The size is the magnitude of the complex number that we have been getting. Now, the angle or the argument is the direction of the complex number. This means that this complex number is 53.13 degrees above the positive x-axis. And if you look at it, it is in this range. It is less than 180 degrees, but it is more than negative 180 degrees. So this is the solution to example 1.